Okay, this is a lead code question number 3010. What it says was divide an array. Okay, we have the array data into subarray. That means small subarrays with minimum cost. First, we'll see what is the meaning of cost and how many subarrays we need to divide, which is 3. So I have the arrays. I have to divide this array into how many parts? 3 parts. And the cost of these arrays should be minimum. So what is that? We have the num arrays. Let's consider I have the data of the array. Okay, it can be multiple elements. At least it should be having minimum 3 elements. Let's consider I have the data of 1 2 3 1 8 9 10. Now with this data we need to divide into how many arrays? 3 arrays. Now in each array, at least I should be having one element. Since the cost of the element is defined by very first element in the array. For example, if I am putting here 1, then the cost of this array will be 1. If it is 10, 10, then if it is 20, 20. So total cost of the array will be 1 plus 10 plus 20, which is 31. So this is what the cost of the array. But this cost should be minimum. That means in such a way that you should place the number on very first element of the array. It should be try to put as minimum elements. So this is how we can reduce the cost of the array. Now, can we skip the first number? No. We have to consider all the numbers. We cannot skip any of the numbers. You can't take, okay, I have the minimum numbers, only these numbers I will take. No. We cannot ignore any of the elements. And very first thing is first number should be on the first, right? Because we can't start with the second number even though it is minimum, then also we cannot go with the minimum numbers. So there is no option. So first element should goes to very first element in the first array. Now, can we change the order? No, we cannot change the order. We cannot put random numbers, which is minimum number, on the first element and skipping the next element, then going for the next minimum number, then next minimum. No, we cannot change the order. Order should be in this directions. The only option is array can have one element, can have multiple elements, but second sub array should be having at least minimum one element, since the cost is defined by the very first element. Now what is the strategy for this one? So there is no option for this first number. So what I'm going to do is this first number I'm going to place as it is in the first array. This is my first number. Now with this number we'll proceed with second and third. Okay, if I consider these numbers second and third into this one, okay, I can put, okay, this one as 2, this one as 3. Now since it looks like this is a smaller number, so I can start with again 1. Then it is up to you, you can put 8 and 9. Only the remaining element is 10, so I can say 10. What is the cost of these subarrays? So we have to say this plus this plus this. It is going to be 1 plus this one plus this 10. So it is 12. This 12 cost, can we reduce this 12 cost in such a way that we should be having the first element minimum? That is the intention of this questions. Okay, now let's consider, instead of arrange taking the very first element in this order, what I'm going to do is the first number, yes, I'm going to take as it is the first number. There is no options. Okay, second number, what I'm going to do is I will take here. Now third number I will take here. This number I'm going to push on the last array. Now what is the remaining element? Since I have taken this one, so all the remaining element I am going to put in the last array, which is 8, 9, 10. So what was the strategy I have taken to get the minimum cost of this array? By the way, what is the cost of this array? It is 1 plus this is 1, this is 2 plus this is going to be 1, it is 4, which is a minimum cost. Apart from this, there is no other solution which is lesser than this 4. So the strategy is, first, no option I have to take. Now what is the next minimum element excluding this one? Okay, since we already taken the first number in the first array, first element. Now the option is on remaining elements. In this remaining element, the minimum number is, what is that minimum number? So let me mark, this is a minimum number, I will say min 1. And what is the next minimum element apart from this first element? Okay, we have taken one. Second, next minimum element is this 2, so I will say this as min 2. Min 1 is the smallest element in the remaining array excluding the first number, and second minimum is 2. So with these numbers, let me mark this as, with these numbers I am going to arrange the element. Whenever I reach any of the minimum element, I will start the next array. Till that point, I keep on filling the first array. Once I get minimum 1 or minimum 2, I am going to start the second array. Once I get again the next minimum, I am going to start the third array. Once I start the third array, rest of the element I am going to fill in the last array. This is how we can reduce the cost of an array. To understand it better, let's take another example. Let's consider I have only 3 elements, 1, 2, 3. 1, 2, 3. So what is the cost should be? Since we are dividing into 3 subarrays and each array should be having at least one element, so there is no option. So it will be 1, 2, 3. The cost will be 1 plus 2 plus 3, which is going to be 6. Now this was simple. Now let's consider I have 99, the very first element, and let's consider this is 88, 80, 70. Then I am getting first a smallest element. Okay, let's consider 1, then 20, then 30, then I'm getting 2. Since I don't have option for skipping the first element, so in my first array I will be having the element which is the very first element. Now this is going to be the first element. Apart from this, the remaining element, when I say remaining element, these all are remaining elements. Out of these element, what is the minimum element? The minimum is this, I will call min 1, and next minimum is I will call min 2. Now I need to continue the first array till I reach any of the minimum, which is up to here. Then with this one, I will start one more array. I will continue till I reach second minimum. Then I'm going to continue the rest of the element. Now 99, I should stop the first array till this position. It is going to be 88, then it is going to be 80, then it is going to be 70. Now this one is, now I'm starting another array. So with this one, I will say 1. Now I will continue this array till I reach this point. Next number is 20. Next number is 30. The moment I reach the another minimum which can be minimum 1 or minimum 2. So I'm going to take a rest of the element. So in this array I will be having just 2. If I have the any numbers, let's say 70, 80, then I'm going to continue with all the rest of the numbers from the second minimum. So what is the cost? Yes, we can't skip 99, so it will be 99 plus 1 plus 2, which is 102. So this is the minimum cost. Since we cannot escape any of the element, unfortunately the first element we should start on very first array. That's the reason I am ignoring in this one. Rest of the element I have the options to find minimum and second minimum, so that I can start the second array and I can start the third array and I will continue. So now let's build the logic. So for building this logic, what we are going to do is, let's consider my numbers are 99, 2, 3, 8 and say 1, then 100, then 200. So my target numbers are, the first number I cannot skip, second number is, which is minimum, is this one, the third minimum number is this one. So instead of third I will say, okay, I have first number I am skipping, the first minimum is this one, second minimum is this one. So I should start a new array from here. Then on the next minimum number I should continue the third array till the last numbers. So what is the time complexity of this one? Since I am iterating one array in single iteration, if number of elements are n, complexity will be order of 1. So for this one I am going to start with, let's say, for loop, okay, for my number n, in which array, let's consider this array is num. So in num I'm going to start with a colon, okay, if it is Python program. Is it correct? If I say num, then it is going to start even the first number, which is wrong, since the first number I'm going to take in the first array. So what I'm going to do is, instead of first number I'm going to say not first number, after first number. So starting from 1, since the index is going to start from which number, this index is 0, this is 1, 2, 3, 4, 5, 6. So I should start from the first index rather than 0 index. By the way, first I will take the first number as, let's consider my first number is this num of 0. This is my first number. Now what is my intention is to find another two minimum number. So another two minimum number, I will say the numbers are, let's say, min 1 and min 2, and I will initialize these two numbers, let's consider as positive infinity. So I will say float of inf in double quote. This is again float of inf, so that these values are maximum. So if I get any minimum values, then I will be replacing these numbers. That's the reason I am initializing these min 1 and min 2 with an infinity. This was infinity, this was infinity. The moment I get very less number, so instead of infinity I will replace with 1. If I get second minimum, I will replace with that second minimum number. Now first condition, very first condition is, let's consider if my number n, this number I am iterating, is lesser than min 1. That means what I consider was min 1 is the smallest number. That means first we need to move min 2 to min 1, then min 1 replace with this n number. So we have to replace two elements. If this is the minimum number, smallest number, okay, min 2 is second smallest element. So first what I will do is I will change min 2 with min 1, then I will replace min 1 with which is a smallest number, which is n. Otherwise, else, if my n is lesser than min 2, yes, it is lesser than second minimum, so I should replace only second element. If it is very smallest element, then first we need to move min 2 to min 1 to min 2, then n to this min 1. Now, since my number is only smaller than min 2, not min 1, then I should replace only one number, which is min 2 equals to n. Then what I need to return is, yes, I got three numbers. What all those numbers? The first number is this first, second number is this one, third number is this one. So I have to sum up all three numbers, which is the cost of the array. So the cost of the array will be the first, I will say very first number plus min 1 plus min 2. Let's understand this logic. I hope this is somewhat not too complex, but let it understand in another way. So let's consider I have two numbers which I will call min 1 and min 2. Now n is the number which I am iterating from the array. Now this number, let's consider the very first thing first will be initialized with 99. So there is no option for this one. So this value will be 99, and min 1 will be infinity, min 2 will be infinity. Now I'm starting from which index? 0 index. Can you see here? This is a start index. This is called slicing. There is no end index till it reaches to the last element. But from which number index I am starting? 1. Since 0 index I already taken as first, there is no option for this one. Only we have the option to minimize the cost is to find smallest and second smallest number. Now with this one, let's consider these two numbers. Initially this value will be infinity and infinity. Now I am on this one. Is it lesser than this one? Min 1? Yes. So what I will do is I will replace min 2 with min 1. Since this is a second smallest number, so I will push this one. So it was infinity, it will be infinity. Now this min 1 will be replaced with what value? 2. Next number is 3. This 3, is it lesser than min 1? No, it is not lesser. Is it else? Is it lesser than min 2? Yes, it is lesser than. So what I will do is instead of infinity, now second minimum is 3, which is right. Till which point? Now up to this point. Now next 8. This 8 number, is it lesser than min 1? No. Lesser than min 2? No. Now the point is next number is fourth index, which is 1. Can you see 1? Is it lesser than 3, or first we need to check lesser than min 1. If it is lesser than min 1, first move this number to here, then replace 2 with 1. This is what I was talking about. First you need to move this number, 2 will be moved to here. So instead of this one, now it is going to be, this will be moved to 2. Now this 2 will be replaced with 1. So first we need to move min 1 to min 2, then move which is smallest element min 1 to n to min 1. That means first move this one, then move this number to here. Otherwise, if my number is lesser than min 2, yes, I just need to replace this number. No need to replace this min 1, since min 1 is still minimum numbers. This is what the logic is. In short, the cost of the array 3 subarrays will be minimum by selecting very first minimum number, second minimum number.